Hey everyone, Mr. D'Souza here. Just like most of you asked, here is a video about solving equations. So I'm pretty sure this video is going to be pretty long, so make sure you use the timestamps down below to go to the parts of the video that you specifically need help with. So let's get the ball rolling. A lot of information here. Anytime we're trying to solve equations, your goal is to get your variable by itself. And remember that you can always check your work. And the way that you do that is you substitute your answer back in and check to see if you get a correct statement. I'm going to show you this when we start doing examples. Ms. James and I came up with this acronym, Don't Call Me Impossible, DCMI. And this is just a reference. If you're ever stuck solving an equation, you can always refer back to this and it will always get you to your answer. And the letters that are highlighted stand for different things. So D stands for distribute, C is to combine like terms on the same sides, M stands for move the variable to one side, and I is to use inverse operations to isolate your variable. If you follow this reference, you'll always get to your answer. So let's do an example together. So if I have a one-step equation, and it's a one-step equation because it's going to take us one step to get there, I got to solve for x. So can I distribute here? No. Can I combine like terms? No. These are not like terms, and this is 10, so we can't do anything there. Should I move my variable to one side? Well, my variable is already on one side. So the only thing that's left is use inverse operations to isolate your variable. Here's my x. I want to move this negative 4 to the other side. The inverse operation of minus 4 is plus 4. So I'm going to add 4 to both sides. I'm going to bring everything down. Negative 4 plus 4 is 0, so that goes away. Bring down my equal sign. 10 plus 4 is 14. But hold on. Why don't we check our work? So check. To check your work, all that means is substitute in your value of x for x. So if our original equation is x minus 4 equals 10, and I substitute in 14, that's 14 minus 4 is 10. 14 minus 4 is 10. Bring everything down. Does 10 equal 10? That is a correct statement, so we're done. So here's about 4 problems that you can practice on your own. Pause the video, work them out yourself. All right, here are the answers to those questions. All right, let's move on. So here are some two-step equations. So we're going to do the same thing. We're going to use DCMI and see what we get. So in my first question, can I distribute? No. So I'm done with that. Can I combine like terms? Well, 3x and negative 5 are not like terms, and 10 is by itself, so I can't do anything here. Do I need to move my variable to one side? No, my x is already on one side. So the only thing I have left is using inverse operations. So here's my x. I got to get this negative 5 and 3 to the other side. So opposite of subtracting 5 is adding 5. So I'm going to add 5 to both sides. Again, you want to try to be neat and organized. I'm going to bring everything down. So 3x. Negative 5 plus 5 is 0, so that adds to 0, as I just said. And 10 plus 5 is 15. I'm going to solve for x. So remember, there's really multiplication in between these two, the number and the variable. So the opposite of multiplying is dividing. So we're going to divide by 3 on both sides. These divide out to 1. 3 divided by 3 is 1. So we're left with 1x is equal to 15 divided by 3 is 3. So why don't we check our work? So check. So we have 3x minus 5 equals 10. So we're going to substitute in our x value and see if it works. So let's do this. 3 times 3 minus 5 equals 10. 3 times 3 is 9. Again, I'm going to bring everything down. I'm not going to skip any steps. 9 minus 5 is 4. Does 4 equal 10? Huh, it doesn't. So that means that my answer must be wrong. So let's go back. 3x minus 5 equals 10. Okay, I can add 5 to both sides. That was right. I can divide 3 on both sides. That was right. But what happened is this part right here. What's 15 divided by 3? It's not 3. 15 divided by 3 is actually 5. So you see how I was able to check my work and then saw that it was wrong and now I can go back? So now let's try. What's 5 times 3? 15. 15 minus 5 is 10. Does 10 equal 10? Whoops. Does 10 equal 10? Yes. So I know I'm done. All right, let's do another one. So this one, a lot of you might say, like, oh, this is challenging because there's a fraction. Remember, fractions are just numbers. There's nothing different. Okay, they just look a little different. But they act and we treat them the same way as normal numbers. So, let's try this out. I want to get x by itself. So I'm going to use DCMI. Can I distribute here? No. Can I combine like terms? No, there's nothing to combine. Can I move the variable to one side? Well, it's already on one side. So that means I must use inverse operations. In fact, these two examples are very similar. If I want to get x by itself, I need to move positive 4 and 1/2 to the other side. So let's start with the 4. The opposite of plus 4 is minus 4. And we get 1/2 x. 4 minus 4 is 0, so that goes away. And 9 minus 4 is 5. Now, a lot of you might get stuck here and say, well, I don't know what to do next. Well, let's go back to this example. I had 3 times x equals 15. You were saying to yourself, okay, the opposite of multiplying by 3 is divide by 3. And that's how we got our answer. Well, this is 1/2 times x. So what's the opposite of 1/2 times x? Well, how about 1/2 divided by x? Or rather, sorry, not divide by x, but we divide by that number, right? So we divided by 3 over here. We're going to divide by 1/2 over here. Remember, when you divide by the same thing, unless it's 0, it equals 1. So on both sides of the equation, we're going to divide by 1/2. And you get your answer to be, so remember that goes away. And you get x equals 5 divided by 1/2 is 10. Now, I challenge you. Why don't you substitute this back into your equation and see if you get the right answer? Well, 10 times 1/2 is 5. 5 plus 4 is 9. So 9 equals 9. So this must be correct. Here's a practice problem right over here. Try it on your own. It's very similar to both of these questions. Try, pause the video, and figure it out. All right. Here's the answer to that question. All right, so we're going to move on to some other stuff. Multi-step. So this is going to take multiple steps to solve this equation. Now remember, as I said in the beginning of the video, there's always many ways to solve equations. I'm just showing you how to use the DCMI method. However, there are a lot of times that you can choose other methods or using other things that you could do to solve these equations. Okay, so don't limit yourself to this. All right, so if I gave you this equation and I asked you to solve for x, and you're like, I don't know what to do. Again, use DCMI. Can I distribute? Yeah, I actually can. This 2 is being multiplied to this difference. So we can multiply that by 2 times 3x, which is 6x. 2 times negative 10 is negative 20. And that equals 15. So I distributed. Can I combine like terms? No, these are not like terms, and 15 is by itself. Do I need to move my variable to one side? It's already on one side. So I'm only left to do is to use inverse operations. And if you notice, if we go back, we're literally doing this question again, but with different numbers. So let's do this together. We're going to add 20 to both sides. And you're left with 6x equals 35. Now, again, just like before, this is 6 times x. What's the opposite of multiplying? dividing. So if I divide by 6 on both sides, these 6's divide to 1, so you're left with x equals, and then a lot of you might be saying, hey, I cannot divide 35 by 6. Well, that's true, you won't get a whole number, but that doesn't mean that your answer is wrong. So there's a couple of options. You can write it as 35 divided by 6, because technically x equals that. Or, if you use your calculator, which I'm going to use right now, you get 5.83333, so on and so forth. Both of these solutions, or rather both of these values, are solutions. However, I personally like leaving it as a fraction because sometimes decimals can get a little messy. Okay? And again, I encourage you, substitute this value back into this equation, and you'll see that you'll get a correct statement. Okay, variables on both sides. Ooh. Again, there's not that much big of a difference. We're just adding a couple more steps. So, first thing, if you don't know what to do, use DCMI. Can I distribute here? Yes, I can. Here's -2 being multiplied to this difference. So we're going to have to distribute this out. So -2 times 1 is -2. -2 times -4x. And again, don't be a hero. Use your calculator if you don't know. A negative times a negative is a positive. 2 times 4 is 8. So I'm left with the x equals 3x plus 8. Okay, so I distributed. Can I combine like terms? Well, on the left-hand side of my equation, again, some people like to do like this, like little train tracks. So we know that this is the left-hand side and this is the right-hand side. Anyways, on the left-hand side, can't combine these. These are not like terms. And on the right-hand side, you can't combine these either. These are also not like terms. So we're done with this. Do I need to move the variable to one side? Well, I have an x over here and an x over here. So I do need to move it to one side. So I like to move, actually let me say this first. You could either bring the 8x to the right-hand side, or you can move the 3x to the left-hand side. Regardless of what you do, so long as if you're using inverse operations, you will never make a mistake. However, I've found that it's a lot easier to move your variable to one side and make sure that it's positive. So, with that being said, I am going to move the 3x to the left-hand side. So the opposite of a positive 3x is minus 3x. And again, let's be neat. I'm going to rewrite everything. So that's -2. 8 minus 3 is 5. So positive 5x equals, see how they're train tracks, 3x minus 3x is 0, so this subtracts 0, and we're left with 8. Okay, got to solve for x. So I move my variable to one side. Let's continue. Now I just need to isolate my variable by using inverse operations. So got to get rid of this -2 and the positive 5. So the opposite of subtracting by 2, or rather the opposite of -2, is positive 2. Whatever you do to one side, you do to the other side. So this adds to 0, and you're left with 5x equals, look at those train tracks, 8 plus 2 is 10. I'm going to rewrite it over here. 5x equals 10. Remember, there's multiplication right here. Whoops, let's make that a little bit more obvious. Opposite of multiplying is dividing, so let's divide both sides by 5. X equals 2. Let's actually check this one. So we have -2 times 1 minus 4, but remember x is 2, so 4 times 2 is equal to 3 times 2 plus 8. And to make this a little bit more obvious, I'm going to highlight what I just did in both questions. So let's do blue. So I have an x here, an x here. This is that x, and this is that x. So why don't we combine everything together? So we have negative 2 times 1 minus 4 times 2 is 8 equals 3 times 2 is 6. And then we leave the 8. So we have negative 2. So actually we can, honestly, let's actually do it differently. I can just put this left-hand side of my calculator. So I can do negative 2 times 1 minus 8. And I get positive 14. And then I can do 8 plus 6. That's also 14. Are these statements the same? Is this true? Yeah, 14 does equal 14. So I know that my answer is correct. All right, let's do another one. But this time, we're going to use a fraction. Dun, dun, dun. Okay, so let's choose this color, because why not? All right, a lot of you might say, oh my god, there's a fraction. I don't know what to do. Don't call me impossible. DCMI. Can I distribute first? Yeah. Here's a number, and it's being multiplied to something in parentheses. So, and again, if you don't know what to do, or if I said, what's negative 1/2 times 2? Use your calculator. Don't try to guess. If you really don't know, or you don't remember the symbols, like, a negative times positive and all that kind of stuff, use your calculator. So negative 1/2 times 2 is negative 1. Negative 1/2 times negative 6. A negative times a negative is a positive. 6 times 1/2 is 3. And we're left with x plus 5. If you notice, we're right now at this step. See? Can I combine like terms? There's nothing to combine here. Nothing to combine here. So I'm done with this. Do I need to move my variable to one side? I do. Now, again, you can move this. Remember, there's an invisible 1 here. The coefficient of a variable is always 1. I can move this over here, or I can move this one over on this side. Remember, there's 2 sides to an equation. So, again, I like to do it so everything's positive, so I'm going to move this one. This adds to 0, and you're left with 3 equals 1 plus 1 is 2x plus 5. Done that. Now I just need to use inverse operations. All right, so I can subtract 5 on both sides. And I'm left with 3 minus 5 is negative 2. Again, don't be a hero. Use your calculator. Bring down my 2x. That adds to 0. We're going to divide by 2 on both sides. And you're left with x equals negative 2 divided by 2 is negative 1. And again, I'll do it with you live right now. Use your calculator to check your work. Negative 1/2 times 2 times negative 1 minus 6. That gets me 4. And then, on the other side, replacing x with negative 1, negative 1 plus 5, that's also 4. Took me 2 seconds to check my work. Now I know if this question was on your test, I know that I'm correct and I can move on. Bam. Let's do some mixed review. This is a Regents question that they gave not too long ago. Let's use my favorite color. So, bam. A lot of you might be saying, wow, this looks really complicated because there's a bunch of fractions. There's nothing different between this question, or how we do this question, and any other question that we just did. Let's use DCMI. Can I distribute? Well, yeah, this 5/6 is being multiplied to this thing in parentheses. So, 5/6 times 3/8. You might say, oh my gosh, I don't know what to do. Use your calculator. I'm going to use it right now to double check my work. So, 5/6 times 3/8. That's 5/16. 5/6 times negative x, that's negative 5/6 x. Okay? Now, just like always, I want to get x by itself, so I got to move this 5/16 to the other side, and this negative 5/6. So the opposite of a positive 5/16 is a negative 5/16. So I'm going to do the same thing on both sides. And again, I'm going to use my calculator. I can't really do this in my head. So why not? Use your calculator. So 16 minus 5/16 gets me this crazy number, 251 over 16. And then this equals negative 5/6 x. Okay? Now, look at what we have. It's negative 5/6 times x. What's the opposite of multiplying? Dividing. So we're going to divide both sides by negative 5/6. Divide this by negative 5/6. And we can do this on the calculator. X equals, we have 251 over 16. I made a mistake. 251 over 16 divided by negative 5/6. So I get my answer to be the following. Negative 753 divided by 40. Or, if you write it as a decimal, which you can use on your calculator, negative 18.825. Now, a lot of you might be saying, hey, that doesn't look like the answer. That's a crazy number. Well, let me check my work. I'm literally going to put it on my calculator. So, 5/6 times 3/8 minus negative 18.825. So make sure that's correct. Okay. And I get 16. If you literally substitute this or this, because these are the same, they're just written differently, you substitute that in for x, you get 16 equals 16. Okay, so don't let the answers that you get fool you into thinking that you're wrong. Okay, have confidence in yourself. All right, we're gonna do 2 more problems. All right, this one looks crazy, but this one actually is not really that bad. This is also a Regents question. Check this out though. They give you the solutions. So there's 2 ways you can do this question. You can solve for x, or you can just substitute each of these solutions into the equation and see which one gives you a correct statement. That would be the fast way of doing this. But I want you to actually try this on your own. So let's do this. Can I distribute? No. Can I combine like terms? Not really. There's some cool algebra stuff that you could do on this left-hand side, but you don't need to do that right now. Do I need to move my variable to one side? Nope, my variable's chilling over here. So the only thing I have left is use inverse operations. So I gotta get rid of this 1/6, the 3, and the negative 2. So the opposite of adding 1/6 is subtracting by 1/6. Whoops. And we're left with x minus 2 divided by 3 equals 5/6. Take away 1/6 is 4/6. 4/6. But 4/6 can be reduced to 2/3. Again, if you do this on your calculator, the calculator will output 2/3. Let's continue. So this is x minus 2 divided by 3. The opposite of dividing by 3 is multiplying by 3. So we're going to have to do that to both sides. And check this out. If we do that, we already know that this is going to divide out because we used an inverse operation, and we're left with x minus 2 equals, if you put this on your calculator, you'll wind up getting this. Okay? So now we want to solve for x. Still, we can use inverse operations, so we can add 2 to both sides. Bam! We get x. This adds to 0. 2 plus 2 is 4. And again, is that one of your answer choices? Yeah, it's this one. Also, if you want to try this out, substitute it back in. 4 minus 2 is 2. So 2/3 plus 1/6 equals 5/6. Well, 2/3 is the same thing as 4/6. 4/6 plus 1/6 is 5/6. Again, you can use your calculator. You should use your calculator. Does 5/6 equal 5/6? Yes. So I'm done. All right. Last question. This one was kind of a crazy one that they put on the Regents recently. But again, you have the ability to do this, right? Don't call me impossible. You got this. So let's do it. Again, this was also a multiple choice question, so all you had to do was substitute these numbers into the equation and see which one gets you a true statement. So let's try it. Can I distribute? Yeah, over here, 4 times x is 4x. 4 times negative 7, 7, 14, 21, 28, so that's negative 28. Now, this is 0.3. 0.3 times x is 0.3x. 0.3 plus 2, if you don't know, join your calculator. So 0.3 times 2 is a 0.6, so plus 0.6. And that's it for distributing, so I'm going to bring everything else down. So you had to distribute twice. Can I combine like terms? So again, let me highlight this. There's two sides to the equation. On the left-hand side, can I combine like terms? No. On the right-hand side, are there any like terms here? Yeah, here and here, right? I can add these two numbers. I'm allowed to, right? So 0.6, so I'm going to do this with my calculator. 0.6 plus 2.11 is 2.71. Now I'm going to bring everything down. Don't forget, that was 0.3 equals negative 28, 4x. Boom. Do I need to move my variable to one side? Yes, because I have an x on the left, an x on the right, so I got to move this person over. So the opposite of positive 0.3x is negative 0.3x. So we're going to subtract by negative 0.3x. Bam. So 4 minus 0.3 is 3.7x minus 28 equals 2.71. I'm going to rewrite this over here so that we have a little bit more room. So we have 3.7x minus 28 equals 2.71. Notice we're doing the same steps and we're still getting the same answer. There's nothing different. We're just using different types of numbers or different, numbers that are just represented differently. Right? So we have more decimals in this one rather than fractions. So if we want to solve for x, we got to move this 28 to the other side. So add 28 on both sides. We're left with 3.7x equals 28 plus 2.71, 8, 9, 10. That's 30.71. Now, I got to get x by itself, so I'm going to divide both sides by 3.7. Divide this by 3.7. And you're left with x equals, let's see, 30.71 divided by 3.7. And that gets me 8.3. Now again, check your work. Use your calculator. Substitute 8.3 back into your equation and see if this is the correct answer. Okay? I hope that this was helpful. If any questions, please email me or Miss James or Miss Fu. We'll always be happy to help you. Until next time, see you later.